Hey everyone, welcome to the channel Codefarm. I hope all of you are doing great. So topic for today's video is unique ID generator. So this is a system that we want to have a design in place, and that is what we are going to discuss. Also, this video is part of the series that we are covering under system design. If you want to check out other videos, the links are given in the description box, and also this is available in the comment section as a first one. I have pinned that comment, so go ahead and check that out to get the complete picture and what all other things that we're covering in this series. That is going to be pretty interesting. So coming to the topic on this one, so unique ID generator. So let's understand first the problem statement, or we say that use case. What is the use case for this unique ID generator? So let's say we are building a software for our company and there are multiple services out there. So first let's say that service that is available out there is a user service, right? And another one is there, that is a product service. So these are the two services available, and there is a respective records coming in for this one, and there are database also for this, each of this, because they are microservices, so they will be having their own databases. They won't be sharing that database. So user is creating the records, right? And each record must be uniquely identifiable, so we can have that ID with this one 1 2 3 4, for example. Same goes for the product. So whenever product record is being created, so we can have that ID available for this as well. So whenever this kind of setup this we have, so when we are in this context only, user context and product context, this ID is good, fine, right? So because same ID is in here, also same ID is in here as well. This is good, pretty good, not an issue. If we have such a requirement, this is fine. But in a distributed system, we need all other use cases, right? So what all those are? So we have APMs, application performance monitoring, or application monitoring, you can say. We have those tools available where all the logs that are being generated by user service, product service, and other number of services, they are pushing these records. Okay, and whatever user ID it has, whatever product ID it has, it is going to be pushed, and all the logs are going to be represented in a single system. So you are getting that idea, right? So whatever data that we have in here for the user, product, and other services is going to a single place. Now for the debugging purpose, if I got hold of one ID, that is let's say 4 is there, and I want to search throughout the APM, so I can search that ID, and I will be getting multiple records for that one. One record will be for the user, one product, and others also can have that ID available. So you see, I want to have that. When we have this ID, I want to have this entity. I do not want to constrain myself in this user boundary and this product boundary only. I want to have that record uniquely identifiable throughout my system. So if I have that ID, so I search that in that APM, I should be getting that record only to avoid any confusion. So the next requirement is to, so this auto increment or whatever ID that is being locally generated is failing here. This requirement is failing here. That is the core requirement of the distributed systems that we have nowadays. Okay, so these are the two use cases that we want to solve it, to have a uniquely identifiable and other things. Let's see what other requirements that I want to have. So first, uniqueness must be there. Numerical values should be there. There should not be any alphabet in that one. Space optimized. What I mean by this one, so if you see, in distributed system there are huge number of records being created, right? So we have to be very cautious how much size we are adding for each and every attribute. So if my ID, unique ID generation requirement can be fulfilled in a 64-bit, I will not go for the 128-bit. So whatever less bit can we can have, we will go for that one. That is what space optimized. Time ordered, I want all the IDs that are being generated, they should be ordered by time. Fit for distributed system, when I say that fit for distributed system, they should be scalable, they should be fault tolerant, and there should be least latency whenever we are generating that ID, and also there should not be any single point of failure, because that is going to be used throughout the system. How security comes into picture when we are dealing with the unique ID generation? So let's say we have the ID that is being generated 1, 2, 3, 4 like this one, right? So you see, if we are sequentially incrementing this one, the next ID is very much predictable, 5, 6, 7, 8, 9 and 10 similarly, right? So it can be incremented by 1, it can be incremented by any other pattern. So the thing is that it should not be predictable. When this ID is predictable, it can be used by unwanted actors for some purposes that is not intended. So that is one need that we have, like our unique ID generation should be unique, like it should be very secure in that sense. So with these requirements in mind, let's see what are the available options that we have. So one point to note here, when you are discussing these things in an interview, so there will be back and forth discussion, all right. Interviewer will present you with certain set of requirements, all right, and that requirements should go via a discussion. This is very important in case of interviews. If interviewer had said that have a system design about unique ID generator, do not go with the solution right away. Have the requirement in place, that what is the requirement of your unique ID generation that you want to have. So have that discussion, note that down. Based on that, choose what the available options that we have. Because in many cases, the unique ID generation system can have a very simple requirement that I just want a unique ID. Give me a way that we can have. So we can have a very easy option. In that case, there is no need to have a very complex system in place if it is not serving any purpose, all right. So keep in mind that have a back and forth discussion, close down the requirement, only then choose the options that is there. So for our discussion purpose, so that we have that concise idea what we are going to discuss it, I have documented it like what all the available options that we have, just for the summary purpose, so that you have a high level idea. First, we are going to discuss about the database auto increment, then we are going to discuss UUID, then we are going to discuss options that is the central server to have a unique ID generation, and the Snowflake is the last one that we are going to discuss. So let's go ahead and see one by one and see their pros and cons and come up with the final approach that which is best suited for our requirements that we have discussed. So first, let's see database auto increment. So for this database increment, so for this one, we have a database for each of our services that we have, right? And any service that we have, right? So let's see S1, S2, S3. So you can think of it like user, product and order microservice that is there. This is connecting to this database and they can get the unique ID generated that we discussed in our problem statement initially, that databases like MySQL, Oracle and others, they provide inbuilt functionality to auto increment the records that are inserted into their system, right? So whenever you are inserting it, you can have that facility available, auto increment the record. So every record that is inserted, that can have a auto incremented that one. So what is the process of this one? This is very simple. It maintains that consistency and transactional integrity is there. So and that transactional integrity and all that is there. So I just it will be available in that sense only, that S1 will have its own ID, S2 will have own ID, S3 will have own ID. So consistency will be in that context only. So this ID 1 can have in here, in here, in here also. That is what that we do not need as per our requirement. So it is, if there is a requirement to have such thing, it is very good to go with, not an issue. So it provides those advantages like that we discussed, like simplicity, consistency, and transactional integrity also. What are the problems that are with this one? Scalability issues are there, performance bottleneck is there, and single point of failures are there. So whenever, apart from this, that would be discussed, this one like consistency is in this context only, that is something that we do not need, and there is single point of failure. If something goes wrong with the database, we cannot have that ID available in that sense. Okay, so let's move to the next options that we have. So database auto increment option is also very well implemented and is being used in the industry. I'm stressing on this again and again. It's about the requirement what we have. Okay, so focus on this one when you are interviewing it or whenever you are implementing in your ecosystem. Unnecessarily, it is not needed to have a complex system in place if it is not serving any purpose, because later on it is very difficult to maintain. The second one that we want to discuss is UUID. UUID, that is universally unique identifiers. They are 128-bit numbers. They are composed of 16 octets and represented as 32 base 16 characters. So UUID is a library that can be used to have a unique ID, and they are unique in such a way that they are a combination of numbers and alphabets. And if I have to say that how they are represented, their length is 128 bits. We want to optimize the space, right? So if we can have certain way that it can reduce this number of size, it is fine. And another requirement is also that it should be sortable by time, that we discussed, and that is something seems difficult with this one, but let me show you the options that are available with us. So if you go to Google and search for the unique ID generator, here you will see this online tool available. So here there are two options, version 4 and version 7. Click on each of this one. So online unique, this is the version 4 UUID. So this is how this UUID is represented, and this is unique in such a sense that it is very good. Like there is a least chance of conflict on this one. It is very much used, and there is a least chance of conflict on this one. Very good thing is like this is available as a library. There is no need of any server as such. It can be locally generated and it maintains that uniqueness throughout the system. Internal algorithm is implemented in such a way that that library can be used, which is available in mostly all the programming languages, like in Java also. Java util is there that can be used to this one. For our purpose, just to showcase the example how it is represented, I am using this online tool that can have this one. Okay, ad is coming in here. Okay, so this is how it is represented, and if I refresh it every time, it gives me the one more ID there. So you see entire thing is changed. 5, 4, 7, everything is changed here, right? That is how it maintains the uniqueness. This is the version 4 UUID. Let's see the version 7 UUID, and I will tell you what is special about this one. That is the recent development. If you have seen older system design about unique ID generator, you won't be possibly seeing this one, because one of the most important criteria that we need, that our IDs should be sortable by time. If it is available there, we do not have to maintain that any create date, update date, just for the sorting purpose. So let's see how it is doing this one. So the size is still 128-bit. It is alphanumeric. All the numbers are there. This version 7 UUID. So notice if I refresh it, this will be regenerated. Okay. So notice how many things are changing in this one. Let's see first one. First representation that is there, 0190F7. Rest of the things are changing. So okay, refresh this again. You see this remains same, rest of the things are changing. So the implementation is in such a way that there can be a time factor into this version 7 UUID. Okay, so if you use version 7 ID, you can use this for shorting the time as well. That is the thing that I wanted to explain in here. So but the only thing is that it is 128-bit. If we can have something around 64-bit, still we want to explore other options. So let's move ahead to the next one. That is a central server that we have. So if you revisit the auto increment options that we have, so that was local to that service, right? So if we had S1, S2, S3, S4, these are the services, right? And they had their own databases to have that unique ID available. So they have their own database. That is why there was the problem that there was a conflict in the ID. One ID, one as a unique identifier is available in here, that was available in here also, that was available in here also. So if somehow we can have that increment option available, like delegated to a central server, to have that unique ID generation. So whenever this is connecting, all the services are expected to connect to this one. Okay, this is also connecting to this one. So whenever this service wants to can create any record in the database, it can connect to this database and get the ID available. So let's say it has given 1, 2, 3, 4 ID to this one. So whenever next is connecting S2, it will give the next ID that is available. Let's say 1, 2, 3, 4, 1, 2, 3, 5, but it won't give this one. And similarly, if S3 is connecting, it will give 1, 2, 3, 6. Let's say S1 is coming again to get that ID. So if 1, 2, 3, 6 ID is used, so it will give this 1, 2, 3, 7. So the problem of having globally unique ID is solved with this one, right? And the security part that was there, that it should not be predictable to have what is the next ID available, that is also not possible, because with S1 the initial ID was 1, 2, 3, 4 and the next ID available is 1, 2, 3, 7. So we can have certain pattern to increment this one so that it is not predictable by anyone, so no one can use this one, right? It gives us those flexibility. And if I talk about the benefit and pros of this one, this is because we are having a single server for this one. It meets all the requirements. It is highly scalable. We can have multiple instances in place, and also how to maintain these IDs with this single server. We can have highly efficient data storage in place. We can have Zookeeper to maintain these IDs and all that, all the servers that are there. We can also use Redis to have this increment available, to have this central server. So it gives us high throughput also, and flexibility is also there to configure the patterns that it is auto incrementing and all that. Okay, so these are the things that it is coming with that one negative options that is there. So if something goes wrong with this server, all of the services will be impacted which are connecting to this one. Unique ID is something that is very critical to each and every service, and if something goes wrong for even a fraction of second, this will impact the entire system. That is something that will take entire system down actually. That is something that we do not need. So this is the major disadvantage of this one. It is not that it is not being used in the industry. So if you use, like if you have, I think that name is Flickr. Flickr is the website provider that it has implemented this way of uniquely generating the ID. So they name their unique ID generation system as a ticket master. So I will provide the link to go through more details about this one, how they have implemented, how this is serving their purpose. So it's not that it is not used in the industry, it is used, but it's about the requirement. Okay, so if you fits this requirement, very good to use this one, right? So because we still have some of the shortcomings in this one, like that is the one like single point of failure. So if we know this limitation, why not solve it with other option that is available? So coming to the last one, that is a Snowflake. Snowflake is a way, you can say it is an algorithm to generate the unique ID. This is where this was invented, or you say where this was created. So Twitter had created this one, and later on they open source this one. Twitter, after this, which is renamed to X after Mr. Elon acquired Twitter. So this is new name is X. So Snowflake is invented or created by this company, and they have open sourced the way algorithm that can be implemented by anyone. So let's see what is the structure of the ID that it looks like. So they are using timestamp as a structure of this one, like first 41 bits. Then we have a data center ID. So these are the factors, these are the components of that algorithm that needs to be there. Worker ID is there, sequence number is there, that is a 12 bits, and there is a toggle bit or sign bit that you say 1 bit. So in total, if you say 41 plus 5 plus 5 plus 12 plus 1, it makes it to 64 bit. Okay, and this algorithm is in such a way that we do you do not need a central server. It can be implemented as a library, and we can have that library integrated actually with all the services that we have. They can use it and have that ID available, and it fits in all the requirements that we have. It is unique, it is sortable by time, it is fault tolerant, it has a least latency because this is something that we are generating in the service itself. We are not calling any service. It is secured because there is no way that there is no way that next ID can be predicted in such a way. Okay, so this is how it can be done. So these are the components of this one. There is a specific way, like certain steps are there. If we can combine these things, timestamp, data center, worker ID, sequence number, and this one, this can give us a very good unique ID. So now let's understand how these components play an important role, like understand a bit more about these things. So what is this timestamp? This represents a 41 bit. So how this timestamp comes into picture? We can have some custom epoch because we need a certain time from where we can have this time available, right? So it is customizable actually. Like Twitter has its own custom epoch from where millisecond needs to be calculated, because ultimately this is something that is going to be represented in numbers, right? And we should have a way to get the decimal out of this one, right? From decimal we can have actual date converted into this one. How we can have this actual date available? Because we have this relative custom epoch available where we calculate the millisecond, convert that to binaries, and that is how it is represented in the database. While converting it back, we can have the decimal representation, and then we can get the date available out of this one. That is how. So if we see how many such numbers can be generated, so 41, so different combination are there. So 2 to the power of 41, which is a very good number, right? So these number of IDs can be generated by having this 41 bits alone. Next comes the data center ID, which is a 5 bits. So how many data center IDs we can have? So 2 to the power of 5, that means 32 data center we can have for this one. Worker ID, it is again 5 bits. So worker ID, that is machine ID, you can say. This is also 32 IDs that we can have. Sequence number, that is 12 bits. So this is an auto incremented ID. So 0, 1, 2, 3, 4, and it can be incremented up to 2 to the power of 12. How it is generating actually? So timestamp. Let's say for each millisecond we have this available. So let's say there is 1 millisecond and there is a request to have a 1 ID. So if we are in the same millisecond, so it will increment 1, 2, 3 and 4. But let's say this millisecond has crossed, like I have got the second millisecond, so it will start again from 0. This is how this sequence number and this is there. Toggle bit is there. So far with these 4 combination we have 61 bits, right? 63 bits actually. And this is 1 bit is there, that is reserved for the future uses. You can say that signed and unsigned bit is named in such a way. So this is for future purposes, and if we add this number, so it makes it as a 64 bit. Entirely we get the 64 bit unique ID, which is sortable by time and all that things factor. So if we have to put in a sequence, so we have this Toggle is coming first, then we have time instamp, then we have data center, then we have worker, then we have, so this is how, this is 1 bit, this is 41 bit, this is 5 bit, this is 5 bits, right? And then we have sequence number that is here 12 bits. So in combination this makes it this makes it a 64 bit. That is how it is implemented. So these are the steps that are there, and these are the different options that we have available so far that we discussed. So let's conclude this video with the comparison of each of that is available out there. So database auto increment, pros, it is simple, consistent, transactional integrity is there. Drawback is that scalability issues are there, performance bottleneck is there, and single point of failure is there, and there is a context, like it is not globally unique whatever ID it is giving. UUID 7 and 4, that is, it is globally unique, time ordered, and widely used. It has a larger side, and it is a complexity. I'll avoid this one because we get that library available out of the box. Only constraint is that it is a 128-bit size. Central server like Ticketmaster, it is scalable, high throughput, flexible, and gives the globally unique ID. It has a complexity, it has a latency issues because now we have to make a network call just to have an ID. Single point of failure, that is there. Last one, that is Snowflake algorithm. It is scalable because we are using locally. It is ordered by date, high throughput, fits in 64-bit, and it is distributed in nature also. Requires clock synchronization, slightly complex implementation. Why we say that clock synchronization? Because it highly depends on the time. So that time, if we are choosing to go ahead with the library, so that time can change. We have to make sure that all the instances that are generating the ID, they are clockwise, they are synchronized actually. If we can make sure that one, Snowflake is the best way to go ahead. Again, it gives you, you have to implement it, whatever the steps are there. So whatever the requirements that are there that fits in, any of these can be chosen. It is not that, because all of them are proven and they are being used in the industry in one or the other way. So it's about the requirement only, right? So what is next coming in? So different options we have discussed, right? So database increment, something that is out of the box available. UUID version 7, timely ordered, that is there. How we can use it? Do you want to see the implementation of that one? If I see the UUID 4, version 4, that is pretty much in use and everyone aware about it. But I see, when I search Google, I see the limited article, limited details about a UUID version 7. You want to see more details about it? Central server, do you want to see this running? Do you want to see this running implemented in a service? Snowflake algorithm, do you also want to see this implemented? Let me know. I'm going to implement this one or the other way in future videos. Let me know in the comment section which one of these you are using in your projects, in your companies, and which one of these you want to see the first implemented on this channel and that video available. So let's have the discussion in the comment section, and let me know if this video was useful and what is the next topic that you want me to cover. And make sure to check out the other videos that are available on the channel. The links are available in the description. The system design series, I'm going to cover that in a very comprehensive way. So please make sure that you check that out. I'll see you in the next video with the next topic. Till then, take care. Bye bye.